today's topic is non-restoring division algorithm. This is one of the division method which is used in the computer architecture for performing the division operation. So to perform this non-restoring division algorithm, we all need of 4 input values such as A, B, Q and C. Here A, initial value of A will be set as 0 and the value of divisor will be assigned to the variable B and the value of dividend will be assigned to the variable Q. Then C indicates the number of bits which is available in your divisor and your divider. So these are all the 4 input values. In the first step you will be assigning the input value for all the 4 variables, and the next step, second step is we have to perform the left shift operation of the variable A and Q. And after performing the left shift operation based on the A value, we will be performing our third step. If it is A less than 0, that is A is greater than 0 or less than 0 is the condition. When the A value is less than 0, that is negative. How to find whether a number is positive or negative? By using your sign bit. If it is a sign bit is 0, it indicates that it is a positive number, and if your sign bit is 1, it indicates that your number is a negative number. First, whether we have to check whether A is a positive number or negative number. If A is a negative number, that is if it is a positive number, then we have to perform A minus B, and if A is a less than 0, that is negative number, then we have to perform A plus B. This is our third step. Based on the value which we are obtaining in our third step, we have to set our Q0 value. For that also we have to check whether A is a positive number or negative number. If A is a positive number, we have to set the Q0 value as 1, and if A is a negative number, then we have to set the Q0 value as 0. Once after completing these 4 steps, next we have to reduce our count value to minus 1. That is count minus 1. If it is 5, we have to perform 5 minus 1, 4. If it is 6, 5 minus 6 minus 1, 5. So we have to, for each and every cycle of these 4 steps, we have to perform this C minus 1. So next, after once we reach C equal to 0, we have to stop our process, and at the C equal to 0 step, again we have to check whether A is a positive number or negative number. If A is a positive number, we can take the A value directly which we have obtained here as our final output. So if suppose A is a negative number, again we have to perform our addition operation of A plus B, and output obtained from this step will be considered as the operation of this output of this division algorithm. Now we shall see this division algorithm along with an example. So this is the example which we have taken for our non-restoring division algorithm. So here 1011 is the dividend value which we have taken, and divisor value, this is the value which we have taken as a divisor, and it is assigned to the variable B. So now initially we said that we are in need of 4 variables for this non-restoring division algorithm. So we have taken Q variable and B variable. Next 2 variables are A and C. So initially we said that for A we will be assigning all the values as 0. The number of bits in your divisor and divider is 4. So I have given as 1, 2, 3, 4 zeros along with my sign bit. This extra bit is called as my sign bit, and but the value of C is 4, the number of bits in my divisor and divider. So 4 is the bit, so I have given as 4 for my C. So in my first step, I have assigned all the values for all my variables. I have assigned the value for A, I have assigned the value for Q, and I have assigned the value of C. So here my first step is getting over. The second step is left shift of A. So I have to perform my shifting operation in variable A and Q. So I have just shifted this one to here, next position, and next this one here, this 0 here, and this one will be moving on here. So likewise here, here, and this 0 will be ignored. So this is the left shift operation of A and Q, and this value, this variable value, this bit value will be left empty, which has to be decided after performing your operations. So first I have completed my left shift. Then I have to check whether my A is a positive number or negative number. We have already said that if the sign bit is 0, it is a positive number, and if the sign bit is 1, if it is a A equal to A minus B. So to perform this minus operation, always we will be doing our 2's complement operation. We will not be directly subtracting the A and B values. We will be taking the A value as it is, and we have to take the 2's complement value of B, and we have to perform the addition operation. So this is the 2's complement value of B, which we have already calculated and we have included here. So now this is the A value and this is the 2's complement value of B, and we are now going to add these two values. This 1 plus 1, it is 1 0 1 0 here, 1 carried here, again 1 plus 1 is 0 1 1 0 0 will be here, 1 will be here. So this operation 1 will be 1 plus 0 will be 1, 0 plus 1 will be 1, 0 plus 1 will be 1. So this is the final value of A, which is obtained after performing the A minus B operation. Yeah, so the next step is, based on this A value, we have to set our Q0 value, which we have left empty during the beginning of this cycle. So for that Q0 value, again we have to check whether A is a positive number or negative number. If A is a negative number, then we have to assign the Q0 value as 0, and if A is a positive number, we have to assign the Q0 value as 1 according to our algorithm. So here this A, it is A value is signed with this 1, so it indicates that it is a negative number. A is less than 0. So if it is less than 0, we have to set the Q0 value as 0. So after completing this one cycle, that is your step 2, step 3 and step 4 together is called as one cycle. After completing one cycle, you have to perform your count minus 1 operation. That is, initially it is 4, 4 minus 1, now your count value is 3. Now one cycle has been completed and now we are going to move on our second cycle. So second cycle, again we are having 4 input values, A, Q and your C value, and also we are having our B value. So now we have to perform our first step, that is left shift of A and Q. Again we have to perform the left shift. So this last digit, that is Q0, will be left empty. So since you are performing left shift, so again it will be shifted. So all your operations, shifting operations will be taken and the sign bit will be equal. So next one is based on the sign bit value. It is 1, it is a negative number. If it is 1, it indicates that this A value is a negative number. If it is a negative number, in the second step we have to perform A equal to A plus B. If it is a positive, it is a negative number, we are doing only addition operation. So addition operation, we can directly add the value of A plus B. When it is a subtraction, we have to use our 2's complement concept. When it is an addition, we can directly add the two values. So we have to add, this is A value and this is the B value which is initially given, and we have to add these value and we have got our new A value. Now based on this A value, we have to set our Q0 value. See, this A value is, this is a sign bit. So sign bit is 1. It indicates that it is a negative number. So once if it is a negative number, that is A less than 0, we have to set our Q0 value as 1. If it is positive, we have to set it as 1. So since your A0 value, that is A is the negative number, we have given as Q0 value as 0. Okay, so again after once the cycle is being over, we have to perform our count minus 1 operation, that is 3 minus 1, that is 2. So next we have to move on to the next cycle, left shift cycle. So here we are having first performing our left shift. Again we are shifting our this A value is 0 0 1. This 1 will be shifted here. We have written here this is a empty value 0 0 1, and after performing the left shift operation, we have to check whether A is a positive number or negative number. Since the sign bit is 1, it indicates that A is a negative number. So since A is a negative number, we can directly perform our A plus B operation. So this is the A value and this is the B value. So when we are adding these values, we will be getting what is 1 plus 1, that is 1 0, 0 will be here, carrying it, again 1 plus 1 0, again 1 plus 1 0, again 1 plus 1 0, 1 plus 1 0, your carrying it will be eliminated. So this is our final A value which we have obtained after performing our A plus B operation. So now based on this A value, we have to set our Q0 value. Since it is your final A value is, this is the sign bit and it is 0, it indicates that this A value is a positive number. So if it is a positive number, see this A is greater than 0, so we have to set our Q0 as cycle is being completed, again we have to reduce our count value. When it is getting reduced, it is 2 minus 1, it is equal to 1. So again we have to perform the same set of cycle operations. Left shift of A and Q, we are shifting and this box is empty. So after performing the left shift operation, again we have to check whether A is a positive number or negative number. Here the sign bit is 0, it indicates that A is a positive number. So we have to perform A minus B operation, that is A minus B, we have to perform A plus 2's complement of B. So the 2's complement value of B is 1, 1, 0, 1, 1. So we have to add these two values. When we are adding these two values, we will be getting 0, 0, 1, 1, 1. So based on this value, again we have to set our Q0 value. So here, this is your sign bit, it is 1, it indicates that it is a negative number. If your sign bit is 1, it indicates that it is a negative number, and if your sign bit is 0, it indicates that it is a positive number. So it is 1, so it is a negative number. When it is a negative number, we have to mention the Q0 value as 0. So again this cycle has been completed. And again we have to perform count minus 1, that is C minus 1, 1 minus 1, it is 0. So when it is 0, we can stop our division operation. So after stopping our division operation, for getting the final output value, again we have to check it based on this A value. The final A value is 1, 1, 0, sorry 1, 1, 1, 0, 0. So again here the sign bit is at negative, it is 1, it indicates that A is a negative number. In the last step, if your A is a positive number, you can directly take this A value as your output. If it is a negative number, then you have to perform A plus B. So the A value is 1, 1, 1, 0, 0, and the B value is, that is your divisor value, is 0, 0, 1, 0, 1. So we have to add all those things and we will be getting this last answer, which is the output of your division operation. This is all about your non-restoring division algorithm.